Okay, this is chapter 7.1 to 7.4 physics. كله حفظ. Um, so go over the book if you can. It's very important. There's a lot of information in the book. What was obtained in Rutherford's experiment? Okay, most of the atom is empty space. The nucleus of an atom is positive, and most of the mass comes from the nucleus. Okay, electrons of atom are negatively charged. That's not coming from Rutherford, and the size of an atom is about 10 to the negative 10. That doesn't come from Rutherford. Those are all general. They're known. But what Rutherford found out is that these 3 points. Okay, question 2. Which are nuclides of the same element? Okay, if it's the same element, and it's the same atomic number. Right? It's these two that both have 15. Okay. Oh, question 3. Sorry. What of these samples can be used as radioactive source in Rutherford's experiments? Rutherford used alpha particles, so you just choose the ones that are alpha. Okay, again, this is all in the book. Okay, I can show you over here. They said that. Where is it? Where is it? Okay, it wasn't here, but they said it in. If you go to Rutherford's experiment, okay, he shot a beam of alpha particles. Okay, so remember that Rutherford used alpha particles. Which of the following have the same number of neutrons? Okay, just subtract and see which ones have the same. This is 12, this is 12, this is 12. فيعني just subtract. 5, I guess. Which will be enough? Okay, penetration. Look. من الآخر, I'm gonna tell you this. Go here, book this table, screenshot it, whatever, memorize it. Okay, because 100% they're gonna get questions from it. Even that might not have been in the quiz. Okay. Which one can protect beta particles? Okay, they told us beta particles need 500 centimeters of air or 1 millimeters of aluminum. That's what you need to stop it. So let's go here. Okay, they said 500 centimeters air. Okay, and 1 millimeter aluminum. Okay, so أكيد if I have 20 meters air, it's gonna be able to stop it because all I need is just 500 centimeters, which is the same as 5 meters. Okay, so 20 meters is enough. Lead will always stop. Okay, lead is the strongest stopper for radiation, so it will always stop. 5 centimeters of air? No, we said 5 meters of air. 1 sheet of paper? No, that's too thin. 10 centimeters of aluminum? Of course. They said 1 millimeter aluminum, so obviously 10, that's more than enough. Question 7, as the 6, I think it's the same thing. Alpha particles, alpha are the weakest, okay? They're the weakest. They only need 5 centimeters of air or 1 sheet of paper, okay? So 1 sheet of paper, obviously aluminum will stop it, cardboard will stop it, lead will stop it, but the only thing that won't stop it would be 1 centimeter of air, because they said 5 centimeters of air minimum. Okay. Question 7. Which of the following describes the properties of photons? Photons يعني gamma. Okay, so they are also called gamma. Okay, and again, their ionizing ability كلهم هيدا from the table. Ionizing ability, where is it? Ion pairs 10 بس 10. فبتحط ionize 10 pairs, and they are in straight lines. Okay, الموفمنت تبعهم straight. شوفي, is their speed 6% of the speed of light? No, their speed is actually the speed of light. Are they positively charged? No, gamma does not carry a charge. Okay, this is Chadwick's experiment. Okay, it was in the book on copy paste. He bombards with alpha particles, they become neutrons, those neutrons become protons. Okay, فبتحط alpha particles turn into neutrons, turn into protons. Question 9. Okay, this is easy. What is any nuclear species that has a specific value of Z and N is called a nuclide. It actually could come typing. How many protons, neutrons, electrons? I'm gonna skip this. Just look at them. 26 protons. Subtract 56, 26. You get 30 neutrons. Electrons, diamond is the same as the protons. What happens? Okay, alpha particle is released. Alpha particle is He24. Okay, so if it's released, معناتها it's losing 2 from the atomic number. Okay, and the mass number it will lose 4. Okay. Question 11. The reaction here is shown as a what? You look at the particle here. What particle has 0 mass but positive 1 charge? That's a beta particle. Okay, and it's plus because it's plus 1. Okay, what is it called? It's a positron. The one that has 0, 1 is called a positron. You just have to memorize this. Okay, what is the value of x? Okay, okay, just take a look, add them. X plus 0 equals 12, so obviously x is 12. Question 12. The radioactive material should always be secured safely. What material is best used for lining the box that has radioactive material stored inside of it? Obviously, lead. Lead will always stop it, except okay, it will completely stop alpha and beta, but it will only reduce gamma. Okay, gamma can never be stopped. That's how strong. That's how strong the gamma radiation is. Okay, it can never be stopped. It can only be decreased to 10% of its original value through lead. Question 13. Um, a charged particle is released, okay, if its speed is 0.06 and produces 10 to the power 5 ion pairs, it's alpha. If it's 0.98 and produces 10 to the power 3, beta. If its speed is C is, by the way, is the speed of light, produces 10 ion pairs, gamma. Okay, from the table, again, I can't, nothing to explain. The speeds, velocity تبعتهم and ionizing power. Question 14. Okay, so a radioactive source emits okay, it emits charges. What type of particles does the radiation give out? So you have A, B, C. A has a really high count, B and C have low counts. Okay, always remember. Okay, I'm telling you this and take it as a rule. Okay, if the radiation counter is very low, it doesn't mean it's detecting radiation. This is called background radiation. Okay, so there's no alpha, beta, or gamma involved here, only background radiation. Okay, so the only one that's actually detecting radiation is A, and A is placed near the negative counter, so obviously it's going to attract the positive. And which is positive? The positive ones are alpha. Okay, if I put alpha, I guess if they put beta plus, I guess that should be correct. No, I think that shouldn't be wrong if they put beta plus, but here they put alpha. What material of the shield will ensure a narrow beam of radiation? Okay, what material did we say to ensure a narrow, yani very thin, okay, radiation? We said lead. Lead is the best material for radiation. The tracks here are left by a condensed liquid. Okay, the cloud chamber is always a condensed liquid. They said it here. The cloud chamber contains saturated vapor. Saturated vapor is vapor at equilibrium with the liquid. At equilibrium with the liquid means yani it's condensed. Okay, the radiation that leads to the creation of these tracks are gamma. Okay, gamma are the ones that don't really move. They're just like in these random paths. Okay, and if you take a look here, they're in random paths. Okay, what is true about the magnetic field in the cloud chamber? It's impossible to tell because it's not affected by the magnetic field. Okay, when you have gamma, okay, you can't tell in what direction the magnetic field is because gamma don't carry any charge. So that's why if they ask you and they tell you what's the magnetic direction, it's gonna be impossible to tell because it's gamma. Gamma don't have charge, and I can't tell whether it's positive or negative, where it's moving to which side. So it's impossible to tell because it's not affected because it has no charge. Track 1 is formed by beta, track 2 is alpha, track 3 is شو اسمه gamma. Okay, what is the direction? It's into the plane of picture. Okay, look, this is straight out of the book. Okay, over here, beta will turn and swivel. Okay, alpha will go up, curve up. Okay, and gamma will just stay straight. Okay, it won't wave, it's just gonna stay straight. Okay, so look here. I'm getting spammed. Fuck. So obviously 1 here where it goes down is gonna be beta, 2 is gonna be alpha, okay, and then 3 is gonna be gamma because it's continuing straight. And what is it here? It's into the plane of picture because look how the beta is moving. It's moving clockwise, and always remember that clockwise is in, counterclockwise is out. Look at the beta, don't look at alpha or gamma. Look at the beta when you're determining the plane of picture. Question 17. Okay, a GM tube detects background radiation 750 counts per minute. What is the background radiation? To find background radiation, it's called BR, is equal to counts divided by time. Time has to be in seconds. 750 divided by the time, 5 minutes in seconds is 300 seconds. So the counts here, the background radiation would be 2.5. Okay, what is the major source of background decay indoors? It's always radon. Okay, just memorize it. It's in the book. They gave you a chart for the sources of background decay. I'll show you just in case maybe they will get. Okay, radon. Radon contributes to 55%, and these are the rest. Medical X-rays, internal, whatever. Question 18. The area of the GM's tube circular window is 2 centimeters squared. In the absence of the radioactive sample, the tube's readings are 20. When the sample is placed 6 centimeters away, the tube's readings are 170. What is the detected radiation rate due to the source? Okay, look, if you have the reading, okay, and the background radiation, how do you find the radiation coming from the source? Because look, the total radiation, not the total radiation, the reading on the tube, the reading of the radiation is equal to the background radiation plus the radiation of the source, right? Because what does, like, if I put a detector here, okay, it's going to detect the radiation coming from my source X, let's call it. Come on, there's going to be background radiation all around. So what does it detect? It detects both of these added up. So how can I find the radiation of the source? I just subtract the radiation detected by the background rate. So in this case, we have 170 detected, and the background rate is 20. So 170 minus 20 is going to be 150. Then for part B, they say the total radiation emitted by the source to 2 decimal places. So there's an equation when you want to find the total radiation. Total radiation, okay, total. I mean, you look total radiation. It's detected rate, okay, detected, okay, times 4 pi r squared over a. Okay, r squared is the distance, okay, and a is the area, okay. So in this case, the detected rate, they want the total emission by the source. So what is the detected rate of the source? 150. ف 150 times 4 times pi times r squared, which is 36 because 6 squared, divided by the area, which is 2. Okay, and you're gonna get, I'll just do it on the calculator. 150 times 4 times 3.14 times 18. Because 36 divided by 218. Okay, you're gonna get this. Okay, in scientific notation, this is 3.3912 times 10 to the power of 4. بس أنا بدهم 2 decimal places, so you just take 3.39 times 10 to the power of 4. Okay, question 19. Okay, consider a neutral atom. Okay, what's the atomic number? 26, and the mass number is 54. لا بقولها زي ده. Obviously, when it comes to penetrating power, alpha is the least, then beta, then gamma. Okay, and gamma will continue even after that. I told you it only decreases the speed, but it won't fully stop it. So here the source emits alpha and gamma. Okay, detector A will detect no radiation, detector B will detect gamma, detector C will detect alpha. To be honest with you, right now I'm not really sure why. Okay, why alpha goes down. Okay, they said into the field. Just more. It really matters in what direction the magnetic field is. If it's going into, I think it's the opposite. Okay, so the way I'm gonna let you guys memorize it. Usually it was going up, right? So alpha, but since I think they said into the space, then it's gonna go down. I'm not 100% sure, but if there's someone in the comments who can figure this out, please write for me in the comments. But as of right now, I'm recording this, I'm not sure what to do صراحة. أكيد B will be gamma because gamma continues undeviated, and since there's no beta, up in A there will be nothing detected. But I'm not really sure as to why alpha goes down in this case. I will ask my physics teacher tomorrow. But for now, I think it's because they said into the space. المهم, question 22. This source emits beta and gamma. Like, this is easy, okay? Beta, since it's negative, will obviously go up, okay, and gamma will continue straight. And since there's no alpha, C will not detect anything. And no, that just makes sense. A will be beta, B will be gamma, kaza, kaza, kaza. Question 23. Okay, helium is obviously alpha. Electron is gonna be beta. Has the least ionizing will be gamma, and it's a photon will also be gamma. Okay, an unstable nuclide emits radiation in an attempt to become more stable. This is known as radioactive decay. When it's becoming more stable, okay, radioactive decay. Fusion occurred. What is fuse? Fusion is when two light nuclei fuse to form a heavy. بسيطة. Okay, these are the tracks. تحفظون. Okay, they're in the book. Okay, over here. Hi, alpha, straight lines. Beta is the same, it's similar. They're kind of straight lines, but they're dotted. Gamma is all random lines, okay? So look, the random lines are gamma, the straight lines are alpha, the straight lines that are dotted are always beta. That's it for 7.1 to 7.4. Thank you so much for watching.